Okay, so now let's look at a gentle introduction to logarithms. And just as a little bit of a revision, what we have done in a previous chapter, we said we can write something like 10 times 10 times 10. Instead of writing it 3 times this 10 times, we said we can write this as 10 to the power of 3. And of course, if we calculate this would give us 1,000. We said this part here, that is called the base, because it's at the bottom of this sort of calculation. This number here is the power, or sometimes it's called the index, or the exponent. And all these things mean exactly the same thing. And this number, this here, this would be, well, I suppose that would be the value of this expression. So if we have an expression like that, we can easily calculate it. And let's say we want to do that in a calculator. What we would do is we would calculate 10 to the power, and sometimes this is indicated with this little sort of hook or whatever you want to call it, with a little roof or so, 10 to the power of 3, and that would give us 1,000. So far so good. So it's not terribly exciting, but there are things that we can do with it, and we look at it just in this way. But sometimes we have it in a slightly different problem that we need to solve. So, for example, we might have the case where we have 10 to the power of, well, a question mark. We don't know. 10 to the question mark equals, let's say 100. And we want to know what actually is this question mark. Now, of course, our intuition tells us that this question mark must be, the question mark must be 2. And we can very easily check that. We would have 10 to the power of 2, and we know that this is the same as 10 times 10, and indeed this is 100. So it's not, our intuition was right with that. But how do we actually systematically find this number 2? How do we go about? How can we find it out? Because maybe there are other cases where it's not so obvious. So how can we actually deal with, how can we find this question mark in a systematic way? And what we can do is we can use a sort of very simple principle. When we discussed maths of addition and subtraction and used that for rearranging an equation, what we said was we can use the inverse mathematical function. So the inverse mathematical function, let me write that down, inverse mathematical function, basically reverses what we do in the first place. So if we have a number, let's call it say 10 plus 5, we add 5 to our first number, and then the inverse mathematical function would be negative 5, because that would give us again our 10. So the inverse mathematical function of plus is minus. And the inverse mathematical function of multiplication, say 10 times 5, what is the inverse mathematical function that gives us our original number? Yep, you're right. We just simply divide it by 5. So we've got the inverse function, the inverse mathematical function of multiplication is division, because that gives us our original number. And now what we need to really find is the inverse mathematical function of taking a base to the power of something. Taking a base to the power of. We need to find this inverse mathematical operation. And this is actually a function or an operation that again would need to give us our original number again, and it needs to reverse what we have done. And in our case, the inverse mathematical operation to 10 to the power of is here. This is called the logarithm and in this particular case we indicate that we are working with the base 10 by putting the 10 as a sort of a subscript. So now that sounds quite esoteric, let's see how this works with our example. Let's say we've got our 10 to the power of the question mark, and instead of the question mark I make it a little bit more mathematical. Let's say we call it x, 10 to the power of x. This should give us 100, and we want to know the x, and of course we know it as we have seen before. The x is 2, but now we can use this logarithm, which is very often is abbreviated as just simply log 10, because we don't want to write logarithm all the time. And now what we can do is we can use this knowledge and we can apply this operation. So we also know that from a previous video, what we do to one side of the equation, we need to do to the other side of the equation as well. So, for example, what we can do to find this x is we say we take the left-hand side of our equation, log 10, and we usually would write that in brackets. So we've got log 10 of 10 to the power of x equals log 10 of the value of 100. So that is how this would look like. And now we know that log 10 and 10 to the power of something, this just simply cancels each other out. So this is the same as the plus and the minus. These are the inverse mathematical operations, or the multiplication and the division. So log 10 and 10 to the power of, it cancels itself out. So what we've got left is x on that side equals log 10 of 100. And we can now just try to do that with our calculator. So let's head over to our calculator. Here it is, our calculator. So what we need to do is log 10, and we've got a key for that. Most calculators, most scientific calculators have a key where you can calculate this log 10, and this is this key here, log. And very often it doesn't even say that it is to the base 10. So log 10 of the number of our value 100, close the bracket, equals, yes, it's 2. That was also what our intuition said. Log 10 of 100 equals 2. And that is what we originally said, but now it is in a more formal way. Now let's look at another example. Say we have 10 to the power of x equals, say, 10,000. And again, we want to find out what x is in this case. So x equals, well, that's what we need to find out. And now we know how we do this. It's very simple. All we need to do is, and let's write this down again in the formal way. We need to take both sides of this equation log 10. So log 10 of 10 to the power of x equals log 10 of 10,000. Like that. And again, we know that log 10 and 10 to the power cancels each other out, and on the left hand side we've got x equals log 10 to the log 10 of 10,000. Let's head over to our calculator again. So here we need to find log 10 of 10,000, close the bracket, equals 4. Yes, absolutely. So here x equals 4. And it makes sense because we know that we can write 10 times 10 times 10 times 10, and that would be exactly 10 to the power of 4. Now, of course, you say, why do I need to fuff around with this log 10? Isn't it clear that 10 to the power of x, if this gives me a value of 10,000, that x equals 4? You're absolutely right. But we might run into a situation where we have numbers that are not so nice. So, for example, we have something like, say, 10 to the power of x equals, let's say, 10 to the power of x equals 4. And we want to know what is x. And you say, now it's not that easy to figure out what x is, because it's no longer a multiple of these tens. So we need to really apply what we just learned. So we can say it must be between, say, 0 and I don't know. Well, let's see. Let's see what we can do with our formal mechanism. So what we can do is we can write log 10 of 10 to the power of x equals log 10 of the number of 4. And again, we know that these log 10 and the 10 cancels out. So we've got x equals log 10 of the number 4. And we probably can't do that in our head, so let's head over to the calculator again. So here's the calculator, and now let's do the calculation like we done before. So log 10, but now our number, the value is 4, close the bracket, and we get 0.602, and we see it's a very long number. Actually, it is not an integer, as you obviously see. It is an irrational number, and we just simply go for, let's say, 3 decimal points. So this equals 0.602. So in this case, our x, our unknown, is 0.602, which also means that 10 to the power of 0.602 gives roughly around 4. And again, we can try and see if this is correct. So let's go to our calculator, and again, what we do is we say 10 to the power of 0.602. Let's see if we get close to 4, 3.9994. So yes, we are pretty close. We are not getting exactly 4 because you've seen that when we take the log 10 of 4, it gives us an infinite number of digits actually, and we've just done 3 decimal points, but you see the principle that we can apply to solve something like that. So 10 to the power of 0.602 gives something like 4. Now let's see what happens if we've got 10 to the power of x gives, let's say, 40. Now that's an interesting one, but we know how we can do that. We can just simply take the log 10 of the left-hand side equals log 10 of 40. Okay, so again the log 10 and the 10 cancels out. We have x on the left-hand side equals log 10 of 40. And let's try what we get in the calculator with that. Okay, so let's go to the calculator. Again, we've got log 10 of 40, close the bracket, equals, we get a value of 1.602. And we do it again to 3 decimal points. So this would give us a value of 1.602. So here, our x would be 1.602. And you probably notice, if you look carefully at the numbers here, you see here we've got 602 here and we've got 602 here. And the only difference between that is on the 0 and the 1. So for the 4 we have a 0 here, for the 40 we have a 1 here. And that actually is incredibly helpful when we want to do calculations with logarithms. And I'll show you in the next video how we can actually use that to our advantage to make life much easier for ourselves. So thank you for watching and stay tuned.